All right, so we have talked about series circuit, current, voltage, resistance, parallel circuits. Now, I would like to dive into analog and digital signals because this is basically to fast track you into developing your own, um, writing your own Arduino code and all that. We're still going to we're still going to work on things like capacitance and inductance, but that's when the time arises for us to use them. We'll talk about them. All right, so for today, we're talking about analog and digital signals. All right, so but this video is focused on digital signals to be precise. Now, what are digital signals? They are basically signals that your electronics or your electronic project is going to eventually use to communicate with itself or with stuff, you know. So now, in the digital world, only two things exist, which is a yes and a no, or 0 and 1. Okay, and how do we depict 0 and 1 in a digital signal? You get, so how do we do that? Because we know that everything is represented in zeros and ones in your computer. Now, for electronics like your computer, some other devices, they usually use 5 volts to represent 1 and 0 volts to represent 0. Some embedded devices would also use 3.3 volts to represent a high, you know, and they would use 0, and 0 volts is always going to be 0 or low. So that's basically what a digital signal is. So to plot a graph, just to show you give you a more descriptive info on digital signals. Let's call this time, and let's call this. Let's say this is on. I don't know. Say on. Right. So this is basically a switch. Let's call your light switch in your house when you flick switch, or you just on off. Now, when the time it takes for your light to come on, when let's assume the light is on, so this is going to be off. Yeah, sorry, I'm not using a pen. So now when your light is on, let's say your light is on it's on, and then you flip the switch, you turn it off immediately. What happens? It goes down, straight down to off. It doesn't take some, it just boom, off. And then if you decide to turn it on again, it goes way back up to on again and keeps staying on until you turn it off once again. So this is exactly what a digital signal looks like. Yeah, so it doesn't have in between. It's either high or it's low. So this line usually used to confuse me. This line actually kind of doesn't exist. You get, so this line really doesn't exist. It's just to show you, just for graphical purposes. In real life, this is actually what it looks like, right? So it's on, and then you turn it off, it stops being on, and then you turn it back on again, and then you turn it off, it stops being on. So that's what a digital signal looks like, or that's how things are in the digital world. They're either on or they are off. So how does your Arduino board or your electronic project know what an on signal is or what an off signal is? How it does this is basically by using 5 volts and 0 volts to know what's going on around its ports. Okay, well, you're going to understand this a lot better when we actually use an Arduino board to simulate this same concept that I'm trying to explain. All right, so that's really it for digital signals. Your board sees 5 volt as 1 and 0 volt as 0. Pretty much it. Now, for analog signals, it's a completely different ball game, or a completely different story. Reason is because analog signals will range from probably 0 to 1. So so for an analog signal, just so to give you a kind of an example of what an analog signal looks like and why it behaves the way it behaves, let's do something like temperature. Let's say you're working with a temperature sensor, and this is going to be seconds time. All right, so now let's say the temperature is too high and you decide to turn the AC off, so that the temperature of the room you decide to turn the AC on so that the temperature of the room can start reducing. What's going to happen is, when you turn the AC on, the temperature doesn't just randomly drop. It doesn't do that. What the temperature does, it's gonna slowly drop down, until it reaches a steady maybe temperature, and then it stays there. Or, yeah, basically. So that's what is going to happen. Now, how do you represent this in your board? Like, how are you going to, this is an analog signal, and since your board only knows high and low, um, when you're taking readings from a temperature sensor that's going to be seeing this kind of temperature gradient or temperature wave flow, whatever, when you're taking readings from a sensor that is experiencing this kind of data change, how does your board, or how does your board digitally interpret this data? So luckily for us, there's something called ADC. ADC means analog to digital converters. So they're able to convert analog signals into digital form. All right. Now, how is this going to happen is this is going to be 5 volts as usual. So this is going to be 5 for the highest temperature, and this is going to be 0. So you're going to map the temperature to voltages between 5 volt and 0, right? And the accuracy is actually dependent on how many bits your ADC has. Some ADCs are 16 bits, some are 64, and I think some are 128. So Arduino, I think, is 16, right? So I think that means like 16 divisions per voltage. So let's say inside one, it can divide 1 volt into 16 parts. It can divide. So yeah, don't worry about yourself. That's just accuracy. Don't really carry that to your mind, so doesn't confuse you. So now, as this temperature drops, we are going to be assigning various voltages to them, to it, basically. And in return, what the graph is end up looking like is it's going to end up converting it to something like this. Like, it's going to make it steps. So now remember, digital signals will move in steps, right? So it's going to convert each of these it's going to convert this graph into a step, and it's going to represent it in zeros and ones. So it's going to have like a sequence, you get, of zeros and ones to represent the analog data you're sending in. So Arduinos have analog ports that do this. This is called ADC, analog to digital conversion. So so at some point here it might be like 3 volts, you get. So it's going to convert it into a bits day of data, like it may be 00111 or 00011 something, you get. So yeah, that's basically how analog to digital conversion works in Arduino, in microcontrollers. A very crude, basic way, Now, we're going to go over to Tinkercad and simulate do a bit of circuit simulation, so that you guys can actually see what I'm talking about. We might not be able to test the analog side, but we can definitely test the digital side and wire up an LED to make it blink and all that. I will still try and test the analog side with us. I'm not sure if the simulator will allow because analog data is real world data. All right. So yeah, I'll meet you on the other screen. All right. So yeah, we're back here. I'm going to delete all this. Or do I necessarily? Yes, I think I will have to delete everything on the screen. So this will go, this will go, this will go, this will go, and this will go. Now, so this is actually going to be introduction into so basic LED blinking code stuff. So I'm not going to really dive into explaining all the code yet, because I just want to show you how it works. So now let me